So far, we've learned how to expand signs of sums and differences of angles, like this. Today we're going to learn how to turn products of sines and cosines into sums or differences, and how to turn sums or differences of sines and cosines into products. Let's first find the formula for sine of alpha times cosine of beta. We can use these four equalities as we wish. We notice that sine of alpha times cosine of beta appears here and here in these two formulas. See what happens when we add these two equalities. Cosine of alpha times sine of beta cancels out here and here, and so we're left with 2 times sine alpha cosine beta equals the sum of the sines of alpha plus beta and alpha minus beta. And this is how we get our first formula. Sine of alpha times cosine of beta equals 1/2 sine of alpha plus beta plus sine of alpha minus beta. Again, see what happens when we replace sine of alpha plus beta with this expression and sine of alpha minus beta with this expression. Then here we get that cosine alpha sine beta cancels out, and sine alpha cosine beta appears 2 times, and then the 2 times cancels out with this 1/2, and then we get sine of alpha cosine beta on the left and on the right hand side, so the equality holds. Now what do we do with cosine alpha cosine of beta? Well, we see it here and here. Now we need to cancel out the sine of alpha sine of beta, so we just add these two equalities, then this cancels out, and then we get cosine alpha plus beta plus cosine of alpha minus beta equals 2 times cosine alpha cosine beta. So we divide both sides by 2 and get cosine of alpha cosine of beta equals 1/2 cosine of alpha plus beta plus cosine of alpha minus beta. Finally, for sine of alpha sine of beta, we see it here and here. So to cancel out the cosine of alpha cosine of beta, we just need to take this equality and subtract this equality from it. Then this and this cancels out, and then we get 2 times sine of alpha sine of beta equals the difference between this cosine and this cosine. And that's how we get this formula. Sine of alpha sine of beta equals 1/2 cosine of alpha minus beta minus cosine of alpha plus beta. Now let's work on the expression sine alpha plus sine beta. For this, we're going to make the following substitution. Alpha equals x plus y, and beta equals x minus y. We know that x equals alpha plus beta divided by 2, because when we add these two equalities, the y cancels out, then we get 2x on this side and alpha plus beta on this side. And so x equals alpha plus beta divided by 2. Similarly, y equals alpha minus beta divided by 2, because when we subtract this equality from this equality, the x cancels out, we get 2y on this side and alpha minus beta on this side. Therefore, y equals alpha minus beta divided by 2. So we can substitute alpha with x plus y, we get sine of x plus y, and we substitute beta with x minus y, and we get sine of x minus y. And now, sine of x plus y plus sine of x minus y equals this expression here for x instead of alpha and y instead of beta. And because sine of alpha plus beta plus sine of alpha minus beta equals 2 times sine of alpha cosine beta, similarly sine of x plus y plus sine of x minus y equals 2 times sine of x cosine y. And now sine of x equals sine of alpha plus beta divided by 2, because x equals alpha plus beta divided by 2, and cosine of y equals cosine of alpha minus beta divided by 2, because y equals alpha minus beta divided by 2. Therefore, the formula for sine of alpha plus sine of beta is 2 times sine of alpha plus beta divided by 2 times cosine of alpha minus beta divided by 2. By using similar arguments, we get the other three formulas. Sine of alpha minus sine of beta equals sine of x plus y minus sine of x minus y, because of these definitions. And now sine of x plus y minus sine of x minus y, we can consider sine of x plus y to be sine of x cosine y plus cosine x sine y, and sine of x minus y to be sine of x cosine y minus cosine x sine y. When we subtract them, sine of x cosine y cancels out, and what is left is 2 times cosine x sine y. So 2 times cosine x sine y. Now we can substitute y with alpha minus beta over 2 and x with alpha plus beta over 2, and we get the final formula for sine of alpha minus sine of beta, 2 times sine of alpha minus beta over 2 times cosine of alpha plus beta over 2. Now for cosine of alpha plus cosine of beta, this equals cosine of x plus y plus cosine of x minus y. And now this here appears right there, but alpha instead of x and beta instead of y. So this expression must equal 2 times cosine x cosine y. And then we replace x with alpha plus beta over 2 and y with alpha minus beta over 2, and then we get 2 times cosine alpha plus beta over 2 times cosine of alpha minus beta over 2, which is the formula for cosine alpha plus cosine beta. And finally, cosine alpha minus cosine beta equals cosine x plus y minus cosine x minus y, which appears here, but alpha instead of x and beta instead of y. And so it equals 2 times sine of x sine of y, which I've written here, but we have a negative sign, because this is cosine of the sum minus cosine of the difference, and here we have cosine of the difference minus cosine of the sum. And so we get minus 2 times sine of x sine of y. Sine of x is sine of alpha plus beta over 2, and sine of y is sine of alpha minus beta over 2. So the formula for cosine alpha minus cosine beta is minus 2 times sine of alpha plus beta over 2 sine of alpha minus beta over 2. Here are a couple more useful formulas. The formula for sine of 2 times alpha, which we've seen in previous videos, we can derive it from this equality here by substituting beta with alpha, and then we get sine of 2 alpha equals sine alpha cosine alpha plus cosine alpha sine alpha, which is 2 times sine alpha cosine alpha. Another useful formula is for cosine of 2 alpha. Of course, we're going to use this equality here and substitute beta with alpha. Then we get cosine of 2 alpha equals cosine alpha minus sine alpha, as written here, which equals cosine squared of alpha minus sine squared of alpha. But we can use the fundamental trigonometric identity, which states that sine squared of alpha plus cosine squared of alpha equals 1. And if we replace sine squared of alpha with 1 minus cosine squared of alpha, we get that this expression equals 2 times cosine squared of alpha minus 1. And if instead we replace cosine squared of alpha with 1 minus sine squared of alpha, we get that this expression equals 1 minus 2 times sine squared of alpha. This optional problem is actually a special case of what is known as Newton's theorem. But right now, let's suppose we don't know the theorem and try to solve the problem without it. We have a triangle, this is its incircle, and this point here is the center of the incircle, or the incenter. This is the point of tangency of this side of the triangle in the circle. This is the midpoint of this segment, and this is the midpoint of this side of the triangle. We have to prove that this point, and this point lie on a straight line. And here's the solution. Let's call the sides of the triangle A, B, and C. Then this is the midpoint of this side, therefore this length is C divided by 2. We have that this is the point of tangency of the incircle with the side, and therefore this length is semiperimeter minus B, and this length is semiperimeter minus A, where semiperimeter is A plus B plus C divided by 2. We denote this length by Y and this length by X. We denote the angles of the triangle by alpha, beta, and gamma. Since this is the incenter, we know that this and this are angle bisectors of this angle and this angle respectively, and therefore this angle equals gamma over 2, and this angle equals this angle equals beta over 2. We know that the sum of the angles of this triangle is 180, therefore this angle is 180 minus alpha minus gamma over 2, and so this angle must be alpha plus gamma over 2. Also, let's denote this distance by m and this distance by n. We can prove that these points lie on a straight line by using Menelaus theorem for this triangle and these 3 points. It means that we have to prove that x plus y divided by y times m divided by n times this length divided by this length equals 1. But this length and this length are equal, so we can just write 1 divided by 1. So essentially we need to prove that x plus y divided by y equals n divided by m. But now consider this triangle here. In it, this is an angle bisector which intersects the opposite side and this point, and from the angle bisector theorem, we know that n divided by m equals this side of the triangle divided by this side of the triangle, which is a divided by x plus s minus b, which is written here. And now we can apply the law of sines for this triangle and get that a divided by x plus s minus b equals sine of alpha plus gamma over 2 divided by sine of gamma over 2. But we know that sine of alpha plus gamma over 2 equals cosine of beta minus alpha over 2, because the sum of alpha plus gamma over 2 and beta minus alpha over 2 is alpha over 2 plus beta over 2 plus gamma over 2, which is 90 degrees. We know that x plus y equals s minus a, which is this segment, minus c divided by 2, which is this segment. But semiperimeter minus a is c divided by 2 plus b divided by 2 minus a divided by 2. And when we subtract c divided by 2, we get b minus a divided by 2. Now the law of sines gives us that b equals 2r sine of beta and a equals 2r sine of alpha. And so b minus a divided by 2 equals r times sine of beta minus sine of alpha. Now we can apply the formula for sine of beta minus sine of alpha, and we get 2 times r times sine of beta minus alpha divided by 2 times cosine of beta plus alpha divided by 2. But cosine of beta plus alpha over 2 equals sine of gamma over 2, because beta over 2 plus alpha over 2 plus gamma over 2 equals 90 degrees. The only thing left to find is y. But y equals this segment minus this segment. This segment is c divided by 2, so we need to find this segment here, which we can find from the law of sines applied to this triangle. We have that this side equals b times the sine of gamma over 2 divided by the sine of this angle, which equals the sine of this angle, which equals sine of alpha plus gamma over 2. So we get y equals b sine gamma over 2 divided by sine of alpha plus gamma over 2. And then we subtract the c over 2 here to get the final expression for y. From the law of sines, we can replace c with 2 times r sine of gamma and b with 2 times r sine of theta, and that's how we get this expression here. But then note that the sine of gamma equals 2 times sine of gamma over 2 cosine of gamma over 2. So by taking the common term sine of gamma over 2 out, we get this expression here. And taking the common denominator sine of alpha plus gamma over 2, we get this expression here. And now notice that we can apply the formula for sine times cosine here. It says that cosine of gamma over 2 times sine of alpha plus gamma over 2 equals 1/2 sine of alpha plus gamma, which is the sum of the two angles here and here, plus sine of alpha, where alpha is the difference of this angle minus this angle. The 1/2 cancels out with the 2, and sine of alpha plus gamma equals sine of 180 minus alpha minus gamma, which equals sine of beta. And so we can cancel out this with one of the terms here from 2 times sine of beta. And what is left in the parentheses is now sine of beta from here and minus sine of alpha from here. So sine of beta minus sine of alpha. Now we can apply the formula for sine of beta minus sine of alpha here, and we get sine of beta minus sine of alpha equals 2 times sine of beta minus alpha over 2 times cosine of beta plus alpha over 2. And then we can also write sine of alpha plus gamma over 2 as cosine of beta minus alpha over 2, just like we did here. Now note that cosine of beta plus alpha over 2 can be written also as sine of gamma over 2, just like we did here when we replaced cosine of beta plus alpha over 2 with sine of gamma over 2. So we can put a square in the sine of gamma over 2, and this is the final expression for y. We need to prove that x plus y divided by y equals n divided by m. So we can write now x plus y divided by y by substituting x plus y with this expression and y with this expression. And then we get this fraction here, where some of the things cancel out. 2r cancels out, sine of beta minus alpha over 2 cancels out, and one of the terms sine of gamma over 2 cancels out here. We're left with cosine of beta minus alpha over 2 divided by sine of gamma over 2, which is exactly equal to n divided by m. And so we're done.